era has begun. The age of the Transformers is over.
Don't you get it? We don't need you anymore.
Shouldn't have come after my family.
Okay, now. Yes, we are going to do Transformers today. Yep, that's our topic. But just be aware, the Transformer we are doing is not the Transformer I showed you before. Okay? And yeah, they called Transformers. So let me explain what it is. So, yep. Transformers can be very simple. Assume there is a piece of magnet, okay, even metals, a piece of metals with a hole in the middle. Then what's happening is, let me put some wires through it. Let me use another color. Let me put some wires around one side of this metal or magnet. Okay. Yep. Then let me connect. Okay. Let me connect those wires on an AC power supply. Okay. That's the symbol for AC. Yep, just let me draw it properly. Okay, let's make the top side positive. We have the negative. Okay, the longer side is the positive side. Let's put it with the AC power supply. So remember the unique property of the AC. Okay? If you look at AC graphs, what we can say is the current, or go back here. Yep, the current or the voltage is changing. It's not constant. It's not the same. It's always changing. Okay? So the beauty of this setup is, if I have a current through it, AC current through it, traveling around this, what would I say? Yep, this solenoid. Okay, because the current always changes. Okay? And when we have a solenoid, we produce a magnetic field. So what I can say is there's a magnetic field produced, induced magnetic field, and the most beautiful thing about this magnetic field is its strength changes with the current. Okay? When the current is low, there's more strength. When the current is low, there's less strength. When the current is high, there's high strength. So the strength of the magnetic field changes due to the AC power source here. And this magnetic strength can easily travel to the next side of the metal. Okay? So in this case, if I again, okay, so if I rotate some wires around it, okay, just let me, yep, okay, just let me rotate some wires around it. Okay, yep. What's going to happen is, since the strength of the magnetic field always changes, and sorry, and with the change of magnetic field, Faraday and Lenses told me there is going to be an induced EMF. So there will be an induced EMF. And we can basically transfer electricity without a wire by using the magnetic field to the other side. Okay? Since there's a change in magnetic flux, there will be an induced voltage, induced current. So yep, we have basically electricity. And if we put it there, we can actually calculate the voltage output, the potential difference between these two wires, which is the voltage. Now, what a scientist discovered a long time ago is, remember this number of coils, this N in the formula. Okay? So, say if on the left hand side, okay, on left hand side I call this N1. Okay? If I put N is the number of rotations of the wire on this metal. Okay? If N1 equals to 10 and N2 equals to 20, if the input voltage, say, is 10 volts, the output is going to be 20 volts. They doubled. That's what does a transformer do. The transformer changes the current and changes the voltage and the current. Okay? By basically simply just decreasing or increasing the number of rotations of one side, of wire on one side. Yes, okay. That's it. This is a very simple transformer, and it works. Then you know how does the scientists do things? They make up equations to make, yeah. So, yeah. Let's just go through the equations first. Okay. So if the voltage on one side, the ratio between the voltage on one side, okay, V1 and V2, sorry, the ratio between the voltages is the same as the ratio of the number of wires, number of rotations on one side, number of coils, whatever we want to call it, on one side, and the number of coils on the other side. Okay. Then remember now, okay, let's consider this. Okay. After going through a transformer, the voltage changes, thus the current changes. But what is not changed? Okay. The electricity does not change. It doesn't generate electricity. It just transfers electricity. Okay. It transforms electrical energy to magnetic energy first, then the magnetic field energy transformed to electrical energy again. So the amount of energy does not change. In terms, so what's happening is the power is constant. Okay. The power is constant, and it does not change. Okay. We can't produce energy from it. It's it just transforms or transfers energy. Okay? So using the famous equation, power is measured by voltage times the current. If the power is constant, if power is the same, voltage is going to be inverse proportional to, well, if voltage is going to be P on I, so the voltage is going to be inverse proportional to the current. So in our equation, the ratio of current swoops like this, and the power is constant. Power is constant. That's it. That's the basic equation of transformers. So, so let me give you an example. Assume there is a transformer like this, and sorry, just let me go back for a second. Okay. There's a very important thing. Okay. Now, remember the concept of transformers. If you don't, go back to the beginning of the video. Okay. Transformers only work with AC current. It does not work with DC current because transformer relies on Faraday and Lenz's law. Okay? And Faraday told me there's only going to be an induced, electricity can be produced only when there's a change in magnetic field over time. So if the current is DC, the current is constant, the magnetic field is going to be constant, then there won't be any induced voltage on the other side at the output. Okay, so just make sure transformers only works with AC current. Okay. So let me do that example. Say if I have wires, Okay, so if I have input voltage 10 volts and the input current, say 2 amps, okay, on the left hand side, then on the right hand side, say I have 1, 2, 3, 4. On the left hand side, I have the number of coil will be 2. On the right hand side, the number of coil will be 4. Okay, I can find the voltage and I can find the current using the equation. Okay, if you need to memorize it, put it in your. I show you again. Put it on your formula sheet. Okay. So what can we do is now the ratio between. Well, use the equation V1 on V2 will be N1 on N2 will be I2 on I1. Just remember the current swaps, like the rest is the same. So if I want to find V out, okay, so V1 is 10 volts, okay, V out is there, and N1 is 2. And 2 is 4. Do your math. Okay, V2 on 10 equals to 4 on 2. V out will be 20 volts. So similarly, if you're using the same formula, so V1 on V2 with current, okay, so I2 on I1 equals to N1 on N2, then I out divided by 2 equals to 1 on 2. Okay. So if you do that, the current will be 1 amp. Okay. Then what you can always check your answer. Okay. On the left hand side, the power equals to Vi, the power is the same, so it's 10 times 2, which is 20 watts. On the right hand side, power equals to Vi equals to 20 times 1 is 20 watts. This is a transformer. Yep. You may want to, just remember, not this kind of transformer. Okay, I may show you another trailer for fun.
This is the World Cup. And the World Cup is where everyone...
This is the greatest advance in modern physics since the splitting of the atom.
A rare metal. Molecularly unstable.
It's what they're made of.
Bring it up! All the way! You guys have never seen a truck like this before.
Dad, you can't keep spending money on junk.
I don't think it's a truck at all. I think we just found a transformer.
I'm gonna ask you this once. Where is Optimus Prime?
After all we have done, humans are hunting us. But I fear we are all targets now.
What is that?
Who sent you here? This is not war. It's human extinction. How many more of my kind must be sacrificed?
You gotta have faith, Prime. Maybe not in who we are, and who we can be.
I'm not leaving my dad.
We need a new army.